I'm Danny Riddle. I'm a GIS specialist with SYNCADD. We have Chris Carl. He's a software developer. So the first project that we did was kind of going in between spatial and non-spatial, and it involved using a FME server to upload user data in a variety of spatial formats. But we're really interested in metadata, attributes and things of that nature. So we wanted to validate that using some of the government standards and export that into spreadsheets. We would have manipulated the data ourselves, but there's some data control, data access issues that we couldn't actually manipulate it. So next slide. So what we did is we developed some custom transformers, and some of the transformers that you've actually seen Dale use earlier in the slideshow. The readers we used were Schema readers, Esri stuff, and some SDE geodatabases. So here's some screenshots. We used a variety of methods, and one of the reasons we used FME was that because we wanted to allow users to update these, since standards, obviously they change, through time, and writing code was just not going to be the most cost-effective method. So any user can go into these and change one of the users. So we used a variety of testers. Next slide. So here's an example of some of the reports that we generated. So they came from the geospatial data, and we outputted them with Excel spreadsheets. So the users were able to actually download this through our FTP server from FME Server, and they were able to review it and actually join some of that spatial data and non-spatial data to make their corrections. So that's kind of what we did. That was the non-spatial and geospatial world colliding. What Chris is going to talk about really is completely non-spatial.
Hi everyone. I'll just continue here. So yeah, for this project, what we're working on is completely non-spatial. It's Microsoft Access ETL process that's been maintained over a number of years. It is just a regular transformation process, taking data every quarter out of one database, importing it, and using it in another database. And it's really just been, there are so many workarounds and other little things that have been changed in this process that only really one guy who maintains the Access database really knows everything that's going on. And you have to go into the SQL code and go into all of these steps of scripts inside this Access database to really have any idea. And then just trusting that data that comes out of that and the QA/QC of that is extremely difficult. And that is something that we're working on, and just evaluating and documenting the entire process, and then trying to reproduce it in something that can be maintained and understood by a larger group. So I took this on, and we're using FME to do this. And the main reason is just to get those visual diagrams out there and get all the steps organized into custom transformers, and then to visualize all that, and then visualize the QA/QC as well, to actually add the testers in there, and to be able to say, here's an inspector, here are the values, here's the results that are coming out. And to do that in a way that we can just sit down, on a screen share like this and just show it to everyone that has a question. Next slide, please. So this is just before. I don't expect you to actually read this or understand this at all. This is just nice, messy SQL query that we had in Microsoft Access. And there's a lot going on here. It's moving different things around. It's putting data and unioning it back together. And Microsoft Access doesn't do a good job of formatting the SQL, so it's even easy to read. And they want you to use their design view, which is confusing. So there's no way that our business experts, our subject matter experts, or even a lot of our data analysts, have any idea what this is really doing. Again, only the person that wrote this and maintains this can really explain it. So if we move to the next slide. So this is after. This is essentially doing the same thing that big blob of SQL was doing. And I can explain it now that I have a picture here. So the data is coming in. We're identifying different scenarios in the data, different cases. This is, where one value is there and the other value is missing, and different combinations of that. And the quick explanation is we have a primary measurement and a secondary measurement, but the primary and secondary don't really mean anything in the data that are coming in. They're just randomly populated, at least from our perspective. So we need to figure out what they are, and then make primary something that's meaningful. We want, so we want to move an area measurement into primary, and we want to move capacity measurements. So that's area is like square footage. So this is building facility data. So we'll move the area data into primary, and we move the secondary capacity information, number of people that can fill that space into secondary. We have to identify all these cases where we need to swap these values around, and that's where all these links are doing. You're swapping different values. You can see this is a custom transformer, and then we have additional custom transformers linked inside of this to actually handle the swapping of the different values, and then we add a flag onto it, flag attribute, just to say this is something we've updated, and this is the scenario that we updated it for, so that later on we can run the quality checks to see if by swapping these values we introduced artifacts into the data. All right, so I guess next slide, please. So one way we can do some of that checking of the data is to use that FME Data Inspector that Dale showed earlier. That really makes it easy to just do that on the fly. You can add that in. You can add inspection points as well. And I think that really helps when you're sitting down and discussing these workflows with the rest of your team. You can jump in and say, okay, we see this link here. We're excluding these 50 values, and we want to see what they are and take a look and figure out why they're being caught by this business rule that says if this value is null, we don't want it, or things like that. So we're doing a lot of that here throughout this process. We're checking the data. We're dropping things that we don't want because they're bad. We're merging a couple data sets together, and then we're cleaning them up and even aggregating the data to sum up those measurements based on a group by clause. And then passing it on to the next step. So this is something you would do in a relational database. There's a where clause, there's a join, there's a group by, and there's some renaming of attributes. But this is all done in a visual way where we can jump in and look at the little pieces. And then the other idea that we had with this that everyone really likes is we can take these custom transformers once we've run them with these numbers on the links, print them out, put them in a notebook, and then the next quarter when we run this import process again, we do the same thing, and then someone can sit down side by side with a red marker and say, okay, this value looks like it's really different. This doesn't make sense. We shouldn't have this, and actually just compare each time visually on paper, and that's something that people really like. They can get in and take their time with it and understand the process that way. Next slide, please. So this is just a screenshot of Data Inspector again, where I've gone in and pulled some of this data to evaluate it. So I think you've seen this already. But this is extremely helpful to be able to come in and do this. And then we can also do things like just export the data directly to Excel at that point. And give that to someone that needs to take that back and evaluate it. So just the ability to go in and just drop it to Excel and get that out to someone. So that's the project, and I think it's really taking a lot of what would normally be relational database operations and bringing them out into this to visualize it. So Dale, I'll hand it back to you.
Okay, well, thank you very much. I noticed on the previous slide, if I go there, one thing I wanted to compliment you on was the fact that you rename all of your transformers, which acts like self-documentation, and so we thought that was a really good thing to do.
Good practice.
Good practice. So well done with that. We also thought it was really interesting that you run it in the workbench, remember these numbers, and then use that as a comparison later on. I've never actually heard of that before, but it's a really, really good idea. So
it's not something we've explicitly put out there, but wow.
Yeah, very really good.
Innovative, yeah.
So so anyway, thanks very, very much for showing that to us and sharing with the group what you've done. It's very, very impressive and well done.